Our world is not what it seems. It is governed by principles that go beyond our basic understanding of the universe and stretch the limits of what the human brain can comprehend. The discovery and study of these principles, the foundations of quantum mechanics, have resulted in unfathomable leaps in computing power that stand to change life as we know it. Medicine, security, communications, energy, all of these things could be revolutionized with quantum computing. With the potential for paradigm-changing technology on the table, the pursuit of the ultimate quantum computing solution has led to a competition between East and West, like humanity hasn't seen since the space race. And this time, whoever wins will have more to show for it than a flag on a distant planet. They'll have untold technological power at their fingertips. From the inception of quantum study to modern-day breakthroughs, this is the race for quantum supremacy. Throughout the early 1900s, great minds laid the groundwork for the study of quantum mechanics. In 1900, Max Planck determined that energy is emitted in packets called quanta. Previously, it was understood that energy flowed continuously in waves. 5 years later, Albert Einstein used Planck's discovery to experiment with light, eventually stumbling upon another major discovery of his own. Light packets, known as photons, can act as both waves and particles depending on how and when they are observed. Together, these discoveries established wave-particle duality, a core tenet of quantum mechanics. When combined with Heisenberg's uncertainty principle, the idea that it's impossible to know the exact position and momentum of a particle at the same time, the quantum world begins to slowly peel back. Essentially, the matter and energy we observe every day exists in a constant state of uncertainty at the subatomic level. They are made up of complex particles that exist in many states and locations at once, and only once they are observed does their nature solidify, a concept known as superposition. The study of quantum theory continued, and in 1981, a physicist named Richard Feynman proposed a way to harness the power of quantum mechanics to simulate our infinitely complex world, creating quantum computers. This was the starting gun to the race for quantum supremacy. Further advancements like the 1994 Shor's algorithm, an algorithm that would effectively be impossible for classical computers to solve, proved that quantum computing was possible and extremely powerful. Later that same year, the United States government held a workshop called the NIST Workshop on Quantum Computing and Communication, the first major talk in the quantum computing field. In 1994, NIST scientists created the first quantum logic gate, the building blocks of a quantum computer. And in 1998, a collection of scientists from MIT, UC Berkeley, and the Los Alamos National Laboratory built the first quantum computer in existence using quantum bits, or qubits. Qubits are the units of computational power possessed by quantum computers. They are the evolution of the classical computer's bits, but while a bit can only possess two states, 1 or 0, off or on, a qubit contains those states in superposition, simultaneously on and off, along with all of the possibilities between them. For a frame of reference, the first quantum computer contained 2 qubits of power. The new millennium was kicked off with the Los Alamos National Laboratory building a working 7-qubit quantum computer, but America would soon face a new competitor, China. In 2001, the Eastern nation entered the race when it established the key laboratory of quantum information, where their study of the quantum world was kicked into overdrive through massive government spending. By 2007, the Palo Alto, California-based quantum computing company D-Wave Systems was demonstrating a 28-qubit quantum annealing computer, while China got warmed up by setting a new record for information teleportation using quantum in 2010. In 2016, China successfully launched the first quantum communication satellite, Meechus, and followed that up with a 2,000-kilometer quantum communication system between Beijing and Shanghai, as well as announcing the construction of the National Laboratory for Quantum Science, the largest quantum research center in the world. In 2019, Google pushed the US forward by releasing the Sycamore chip, a 53-qubit processor that was able to complete a complex task that would take a classical computer 10,000 years in just 200 seconds. This victory led Google to claim that the company had achieved quantum supremacy, and this was true at the time. However, China's answer to Sycamore, the Jiuzhang photonic quantum computer, took the wind out of their sails just a year later. By harnessing photons as a qubit medium, Jiuzhang was reportedly 10 billion times faster than Sycamore in certain applications. As we enter the 2020s, it's clear that, while incredible progress is being made on both sides, there is a stark difference between the quantum computing goals between East and West. While the US has increasingly relied on individual companies and corporations like D-Wave, Google, IBM, and others for quantum advancements aimed at commercial uses, China continues to reinforce their status in the quantum race through government spending and national development. In 2021 alone, China completed a 4,600-kilometer quantum communication network, successfully transmitted quantum data between two drones through a particle mirroring process known as entanglement, the first time this has ever been achieved between moving objects, and completed Jiuzhang 2 and Zhuchangji 2, the latter of which is a 66-qubit quantum computer that once again far outclassed Google Sycamore in performance. Google came back swinging in 2024 by releasing the Willow, the follow-up to Sycamore powered by 105 qubits. According to Google, Willow was able to complete a computation in 5 minutes that would have taken one of the fastest supercomputers more years than the age of the known universe. Unsurprisingly, China returned with Zhuchangji 3.0 at the end of 2024, surpassing Willow's quantum power with the same number of qubits. That very same month, China also unveiled Xiaohong to the world, a quantum processor that broke the 500-qubit barrier to present a quantum leap in computing power. In February 2025, the US gained a quantum boost from Microsoft when they unveiled Majorana 1. While it only contains 8 qubits at present, a far cry from Xiaohong, Microsoft constructed the device utilizing multiple technological breakthroughs, including inventing a new state of matter, topological superconductors. With continued development of qubits constructed with topological superconductors, Microsoft says that there is a clear path to a quantum device that could feature 1 million qubits on a single chip. With progress like this being made at a constant rate, it's definitely still too early to call this race. However, with global tensions rising, the stakes of quantum supremacy go far beyond a friendly competition. And, with China's estimated $15.3 billion worth of quantum research and development going entirely towards securing their communications, improving their national security, and using that knowledge to leverage an advantage in other fields like AI, they seem far more prepared for what could come next. One thing is clear: whoever ends up crossing that finish line first will be a technological force to be reckoned with on the world stage, with potentially the power to dictate the course of history. That's it for now. I hope you enjoyed this short tour of quantum breakthroughs. Don't forget to like and subscribe for more tech content. See you in the next one.